Hi, this system is an open trough pyrolysis process, as you can see here, obviously the feeder. This is a combination of screw and paddle-like system in this enclosed chamber. Once it gets into the chamber itself, it will have an open trough that exposes the material to the hot air above it. You can see the gas burner in this instance is all connected and at the moment to the system, and it is a 140 megajoule gas burner, and that just basically gets the unit up to the temperature to around 400 degrees centigrade, and the process itself is self-sustaining. The material will go in the chamber endothermically, absorbing heat from the system, and then go exothermically by start producing syngas. Combustion would happen above it, not in the material, but we exclude air from the trough itself and we introduce air around it. Anyone who is familiar with the Kentucky process, this is a very complex way, and the Kentucky one and open trough system and the continuous system. So we have air that is introduced from below and around, which percolates directly above the open trough where the material is being circulated. There is an air system at the back. Sorry for the absolute mess. We haven't been here for a month and it's been a while since it's been operated. Around the rear we have an air distribution, and as you can see here, this is the system that is sending biochar into the bulker bags. We have a high pressure fan here which has inverter control and regulator for whatever the pyrolysis conditions, feed materials, the temperature that you're aiming for, etc., etc. So it will go in the system through these pipes here. These pipes actually distributes the air, so it goes around, and these are for controlling the airstream being combusted directly from below. So what we're getting is quick combustion in the above pyrolysis zone, which is down on the trough. The systems that we build now, I mean, this is the original system that was built in 2013. It sits outside, so it's weathered, roughened, and looks pretty ordinary, but it's a good one. We love to use it because it's simple, robust, for a wide variety of materials. Our business has been nationally doing research and development work. This machine has produced biochar for New South Wales EPA, the Lucas Spence Timber at Toowoomba Research Station, Monash University, the University of Newcastle, the University of Sydney, also CSIRO. The sugar management system, not sure if it's in Brisbane or New South Wales, but we've built a smaller version of these machines for them so they can operate and trial to produce biochar and optimise the system as well. The latest system that we produce is for a business in Norway, a large one, 1,000 kilogram system that they have more sophisticated air management. There is another system above it, another system above this, because you always get a bit of uncombusted syngas and you need to crack that and the NOxes, CO particles out. Sulfur oxide is not a real issue because sulfur stays in the biochar and there's no issues generally. What else? You know, we basically quench directly on the hot char that comes out, and the double advantage to have that is basically you always have hot char quenched out, and we're aiming to have 20 to 25% moisture, so we don't have any dusting issue or any other occupational health and safety issues to worry about with the dry char. Also, from the agronomic point of view, you condense a lot of these pyrolysis acids, lower carbons that are really good for the soil microbes and the plant, and we condense those onto the char so you get those good smoky compounds that are condensed into the char. The bad smoky compounds are up there, so that's where you want them. You don't want them to show up in the char, but keep the organic compounds away that are the